Hello everybody. Uh, Hello Omar, let's get started.
Okay.
Okay. We are going to continue what we have stopped at actually. Uh, for the last session, we have finished our session on this topic actually. It was about the decimal and binary systems. Okay. At the conversion between the two systems actually. Just 1 minute. I'd like to make sure. Okay, that's good. Okay, let's get back to our topic here. Now we are going to talk about a new thing actually. We would like to make a revision. We are going to review uh, some binary logic operations, some famous or common binary logic operations. Okay, we are going to start with the not operation. Then we are going to talk about OR operation. After that we are going to the XOR operation. Then we are going to make something called left shift and right shift operations. Okay, so let's get started. Okay, the not operation, actually, if you have a number like this, okay, something like this, 11001101, okay, that's a binary number. We are going to make a not operation on this number, so actually it's true. Okay, we know that sorry, I mean that's simple. Okay, it's very simple actually. We are going to make the not operation on this number, but I'm going to make the not operation on this number bit by bit. Okay, so each bit is going to be uh, 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 inversed actually, or complemented. Okay, to have the not of this number. Okay, so it's going to be this one is going to be 0, and the next one is going to be 0, and the two zeros are going to be ones. Then the next ones are going to be zeros. Then we have 1 and then 0. Okay, it's very simple actually. So the not operation makes every one makes it 0, and every 0 it makes it 1. So simple actually. Okay, the next operation is the AND operation actually. uh, we have these numbers. Okay, and we are going to make or we are going to get the AND of these numbers. I would like to revise something. Okay, the truth table for AND. Okay, truth table. I'd like to revise this actually. If you have call it X and Y, then you have Z also, which is the result. Okay, okay, that's it. And now you have X 0 and 0. Okay, 0 and 1. Okay, two zeros, two ones. Okay, this is called a truth table actually. Okay, now we need to get Z or Z, which is X ended with Y. Okay, so it's very simple actually. When you are going to make this operation, 0 ANDed with 0, 0 and 0 is going to be 0, 1 and 0 is going to be 0, 0 and 1 is going to be 0, 1 and 1 is going to be 1. So that's it. Okay, this is called the truth table for the AND operation. Actually, you know that the AND operation, its result is 1 if and only if its inputs, all of its inputs are going to be 1s. Okay, so that's it. It's truth table. So here when I have two numbers, actually, like this example, there is the first number and that's the second number, I'm going to get the AND operation of these two numbers together, bit by bit. Okay, so let's try this. Okay, let's get it from left to right. Okay, so 1 ANDed with 1 is going to be 1, then 1 is ANDed with 0 is going to be 0, then 0 is ANDed with 1 is going to be 0, 0 and 0 it's 0, 1 and 1 it's 1, 1 and 1 it's 1, 0 and 0 it is 0, and 1 and 0 is going to be 0. Okay, so this is the result. Okay, so that's the AND output of these two numbers together. This is the AND operation for these numbers. Okay, going to the OR operation, actually we have these two numbers. Okay, and you are going to make the OR operation for them, but firstly I would like to present the truth table for the OR operation. Okay, so that's it. Now we are going to get, let's make this OR and let's make the first one as AND. Okay, it's better now. Let's try this actually. I'm sorry. Okay, let's make this operation. We have x and y for this truth table actually, and we have this x and y, and we need to get the result for z. Okay, so let's make it 0 ORed with 0 is going to be 0, 1 ORed with 0 is going to be 1, 0 is ORed with 1 is going to be 1, and 1 or 1 is going to be 1. So that's it. Okay, I mean, when you are dealing with OR operation, actually you have these x and y as inputs. Okay, so the result is only 0. It is only 0 if and only if all the inputs are zeros. So that's it. It's very easy also. Okay, now we are going to take a look at these numbers. Okay, we want to make the OR operation on them, so it's easy from left to right. 1 ORed with 1 is going to be 1, 1 ORed with 0 is going to be 1, 0 is ORed with 1 is going to be 1 also, 0 is ORed with 0 is going to be 0, 1 is ORed with 1 is going to be 1, 1 is ORed with 1 is going to be 1, 0 is ORed with 0 is going to be 0, and 1 or 0 is going to be 1. Okay, so that's the result. Of course you see there's a difference here. Okay, this result from the OR is different from the AND. Okay, I think it's clear here. Okay, I think there are no questions for now. We are going to the XOR. It's called exclusive OR operation. Okay, we are going to deal with the XOR operation actually. So let's try this. I'm going to revise it's a truth table actually. Okay, exclusive OR. Okay, so that's it. I mean, I'm going to remove all of this. now we have this truth table. We need to fill it. We have x and y here as inputs. Okay, let's start. The XOR is going to work as like when you find all the inputs are similar, you are going to write the output as 0, and when they are different from each other, you are going to write the output as 1. Okay, I'm going to tell you that there is another rule for it. Okay, let's try it. 0 XORed with 0 is going to be 0. 1 XORed with 0 is going to be 1. 0 exclusive ORed with 1 is going to be 1. And 1 XOR 1 is going to be 0. Okay, this is the truth table for the XOR. Actually, I want to say that there is another rule. We could use it with the XOR logic operation or logic gate. Okay, it's easy actually. When you find your inputs, okay, when you find the number of the ones, okay, when you find that your inputs has an odd number of ones like this. Okay, here you have odd number of ones within your inputs. You have 1. Okay, I mean if you have more than 2 inputs. Let's try this here. For simplicity, I'm not going to fill all the elements of the truth table, but I'm going to say something like you have here 0 and actually 1 here and 1 here. Okay, then 1 here also. Okay, so you see this. Okay, what's the answer here actually? I mean that in this set of inputs, okay, there are no ones, so actually there is 0 ones here within this set of inputs. Okay, and 0 is even number, so the output is 0. Okay, now I have 2 ones here. Okay, so 2 ones is even number also, so the answer is 0. Okay, and now we have 2 ones also here, and the 2 is even number, so it is 0 also. But here we have 3 ones. Okay, and the 3 ones, actually 3 is an odd number, so the answer is 1 here. Okay, you see, that's the XOR operation actually. Okay, I mean if someone has a question or something, please raise your hand. Omar, if you have a question, raise your hand and I'm going to answer it. I mean it's very important for this point to be clear. Okay, go on.
Can we use the relation that we can end the complement of x with y or with the end operation between the complement of y then with the original x?
Say it again.
There is a relation for x or that says complement of x ended with original y. Its result is ORed with the end operation between complement of y and x and original x.
Yes. I think it's true. Yes, this relation is also true. Yes, but I mean for you to solve it, I mean something like in the first moment or by sight actually. You see, if there are something like you have odd number of ones with one input. Okay, so you got your output as 1. Okay, but you are right, Omar. Okay, Okay, we are going to continue. Let's do here our example. We have these two numbers. Okay, we need the XOR of them. So one XORed with 1 is going to be 0. 1 XORed with 0 is going to be 1. 0 XORed with 1 is going to be 1. 0 XORed with 0 is going to be 0. 1 XOR 1, 0. 1 XOR 1, 0. 0 XOR 0, 0. 1 XOR 0 is 1. Okay, so that's the result actually here for this. Now I'm going to talk about something called shift. Okay, I need to make shifting or left shift for this number. I have this number here and I want to shift it to the left by only one place, like I have written here. Please left shift this number by one step or one place actually. So I mean I'm going to shift this number one place only. So I'm going to copy this number here and paste it here. Then I'm going to remove this. I have shifted this and I'm going to write 0 here. Okay, so this is the shift of this number. Actually it's the same order of ones and zeros, but we have thrown away some bits here from the left and we have added some zeros to the right. Okay, so that's the left shift by 1. Okay, what if I want to make this shifted by 3 places? Okay, so I'm going to paste this here, then I'm going to add 3 zeros here and I'm going to remove this. So that's it. Okay, this is the shift for this number. Okay, I mean put these numbers under each other. Okay, so this is the shifting. Okay, I have shifted this number by 3 places, so I have thrown actually I want to yes, I have thrown these 3 bits away and I have all of these. Then I added 3 zeros to the right, these three zeros actually. Okay, you see this resemblance here? This is similar to this actually. Okay, they are two similars. Okay, so it's pretty easy actually. Now it's the same also for shifting right. Okay, I need to shift this number to the right by 1, so I'm going to copy this and paste it here. Then I'm going to add 0 here and I'm going to throw this away. So that's it. Okay, what if I wanted to be shifted by 3? Okay, like this, shift right by 3. So now I have this. I'm going to throw all of this away and add 3 zeros here. If I'm going to have these two numbers under each other, you see that this part actually is the same as this part. Okay, it is the same. Okay, they are shifted to the right by 3 places and 3 zeros are added here, so that's called right shifting. Okay, I think it's simple actually. If anyone has a question or something, please raise your hand. Okay, good. Let's continue. So that's it for this session. Okay, we are going to some new topics here. Now we are going to talk about something called bitwise operators. We had the arithmetic operators, and also we had the logical operators, also the relational operators, and now we are going to talk about the bitwise operators. So let's talk about it. Okay, we have all of these operators actually. This is called I mean, yes, I see. Okay, this is called not, bitwise not. Okay, I'm going to write bitwise here to not confuse you as the logical operators actually. So this is bitwise not, and this one is going to be called as bitwise and. Okay, so that's and this is called bitwise or, you see. And now we have this as I mean, yes, that's it. This is as bitwise x or. So these are our bitwise operators for the C or C++ language. Okay, and these are the shifting operators actually. They are going to be bitwise shifting. So that's it. Now we have bitwise shift right, and this is the bitwise shift left. Okay, you see. Okay, we have an example to run on these operations actually. I mean, I have prepared this. Okay. Okay, let's talk about it. Okay, I'm going to copy this here. Okay, let's talk about it. Okay, let's start with the bitwise not. Okay, here I'm going to make some operation on this number, which is 1 actually. Okay, I have 1 here, and I'm going to get its bitwise not. Before I'm going to proceed, someone could ask me what is this? Okay, why I'm writing this unsigned car here? Actually, I'm using the printf output statement. Okay, and here I have used this format to format unsigned character numbers. Okay, so that's it, and that's a new line here actually. Then I have some value here that I'm going to deal with. Okay, now what is this? This is called casting, type casting. I'm going to cast whatever within these two brackets here to be of the type unsigned character. Okay, in order for the format to work well on this whole expression. Okay, so this is called casting. Okay, I'm not explaining about casting here, but I want to tell you that this is called casting, and you could use it to something like convert from or to make sure that this expression is going to be dealt with as a certain type. Okay, in a certain type actually, which is here unsigned character. Okay, so that's it. And I'm using unsigned character here because this, when you remember, it occupies only 8 bytes within, sorry, 8 bits within the memory. It's 1 byte within the memory, and I need this 1 byte to be formatted and printed here on the screen, so you can see the results clearly, so I can explain very well. Okay, so now let's work on this. Okay, here, okay, let's make this as it is, and let's talk about these bitwise operators. We have something here like we have the number 1, okay, in decimal. course 1 in decimal is going to be something like, okay, this is its representation in the binary, okay. And of course you know that when you are going to, let's have it here, okay, I think it is this session actually. Yes, I see. So that's it. You remember this? It is the same way actually. I have one here, for example, okay. So what I need is to form one from these powers or these weights, okay. So what is the biggest number here that could be subtracted from this number? Actually there are no one of these numbers could be subtracted from this number except this one. So I'm going to put 0, 0, 0 and 0, here also 0, 0, 0, and now I'm going to put here 1, and of course 1 minus 1 is going, we have 0 there, so we have finished here. So this is a representation of this decimal 1 in binary form, okay. So I have this. So remember this shape of 1, okay. Now we are talking, we have printf, okay, with this expression. What is this expression about? Here I have written this tilde, this is called tilde, okay. This tilde represents the bitwise not, okay. It is a bitwise not operation on this 1. So when we are going here, okay, to this 1, actually we know that 1 is going to be this this thing in binary. So okay, let's get its not here step by step. Actually, not of this is going to be 1 1 1 1 1 1 1 0. Okay, so that's it. This one is going to be 0 here, and all of these zeros are going to be 1s here, okay. Okay, what is this number actually? Okay, we could get it. Actually it's very simple. Let's copy this actually here and form it, so you know what is this. 1 and 1 1 1 1 1 and 0, okay, which is equal to, let's try to get it actually. If you have summed all of these, you are going to get 255 actually. Let's get our calculator. It is easy, but our calculator is going to be faster for us. So let's make this operation actually, or directly get this directly here. I'm going to sum all of these together to get the value of this number in decimal. Okay, it's easy. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2, and that's it. 254. Okay, I mean it is 255, but we have decremented by 1, which is this one here for this place, so we got it 254. Okay, so let's run this code. Okay, I have got the not of the bitwise not, actually it is a bitwise not Bitwise operation means that the operation is going to be executed on bit by bit within our number. Our number here is 1, which is equivalent to this. Okay. What is it's bitwise not? Bitwise means that we are going to execute this operation on a bit by bit, single bit by another single bit, and so on. So all of these are going to be complemented to get this number, which is 254. Let's run this, and now we have it. We have 254, which we have calculated here. So we are right. Okay, so that's it. This is called bitwise not. Bitwise not operation on some number or some variable. You could declare a variable and call this on a variable that's called a for example, or something. Okay, you see, that's very easy. Okay, now we are going to talk about another one, which is the AND, bitwise AND operation. Okay. Okay, let's try this. Okay, actually here I'm going to make a bitwise AND here. This is our operation here. I'm going to AND 2 and 1 and get the result. Okay, let's try this here on our board. Actually, what is 2? I mean here that it was 1 here. Okay, now we need to get 2. So how we can form 2? Actually, it's pretty easy. We have these powers here. I'm going to make something like this. It's for simplicity. Okay, now I need 2 here. I need to form the number 2. So what of these could help me for this? I have this power, which is 2, so I want to put 1 here on this, but the others are zeros, so let's make it zeros. And here I'm going to put 1, then 0. Sorry, that's 0 and 1 here, then 0, then it's equal to 2. Okay, so that's it. Now this is 2. Okay, so I mean that 2 is equivalent to this number here. Okay, now we need to make AND. Actually it is a bitwise AND between this number, which we know in binary, and this number which also we know in binary how to write this. Okay, so let's try. I mean, I'm going to get this. Okay, and also this one. Okay, there I need to get the AND of these 2 numbers here. Okay, what happens here? All zeros here are going to be ANDed with all zeros here, so we have these 6 zeros. Now I want to make 0 and 1, which is 0. Also I need to make 1 and 0, which is 0 also, so I got 0. Okay, this is 0 in decimal. Let's run this code to see what happens. 1 ANDed with 2. Okay, I have 0, so I have it. It's true. Okay. Okay. The next operation is OR, bitwise OR. I want to make the operation of 1 ORed with 2. Okay, so let's get back here and change this to OR. Actually, OR. Okay, let's get the result here. A bitwise OR, bit by bit. I mean bitwise, which is this bit with this bit, and I'm going to make the operation on the next bit with the next bit, and the next bit with the next bit. That's called a bitwise operation. Okay, let's start. Actually, these 6 zeros are going to be ORed with these 6 zeros, so I got the result of 6 zeros here. So I have 6 zeros, and then I'm going to make this operation 0 ORed with with 1 is going to be 1, and 1 is ORed with 0 is going to be 1 also. Okay, now what is this number? Okay, it's simple here. I'm going to take this and try this. I have 0 0 0 0 0 0. Sorry, yes, it's true. Then 1 and 1. Okay, so what is it? Actually, I'm going to make my calculations. It is 2 plus 1, which is 3. So this number is 3 actually. So I got 3 here. Okay, so I think when I'm going to run this code here, I'm going to get 3. Okay, which is 1 bitwise ORed with 2 is going to be 3. Let's run this. Yes, I have it. I have 3 here. Okay, so that's it. Okay, there are no questions. The next one is XOR, bitwise XOR. Okay. So that's it. It's going to be written like this. It is ORed or OR. Okay. Sorry, XORed. I'm sorry, XOR. So I need to make the operation of 3 XORed with 2. Okay, how I'm going to achieve this? Okay, so we are going to make the same here. I mean 3 XORed with 2. Okay, I have the number 3, which is this. Actually, I know that this is 3 now. XORed with 2, I know that this is 2. Okay, so this is 2 here. Let's try this. All of these are going to be XORed of all of these, so they are going to be zeros, as they are the same. And here I have 1 XORed with 1, which is going to be 0 actually. And now I have 1 which is XORed with 0, which is going to be 1, and this is called 1 in decimal. Okay, so here I have 1, the result is 1. So what happens if I run my code here? 3 XORed with 2. Okay, I have 1, so it's true. You see? Now I'm going to the next operation, which is bitwise shift left. Okay, so this is bitwise shift left. Okay, it is written like this. How I could read this? Actually, how I could read this? So it is read like you are going to write a number here. Okay, and your shift operator, then another number here. It's going to be read like you have a number shifted, which is shifted left by this another number. It's going to be read like this. Okay, this is equivalent to this. Okay, I want to shift this number by this number. So again, I want to shift this number to the left by this number. I want to shift this number to the left by the amount of this number. So that's it. Okay, so let's get back to here. Here I want to shift the number 1 to the left by 1. Okay, I'm going to put some spaces here to make it easier. I want to shift this number 1 by the amount of 1 bits, you see. So let's try this actually. I want to shift left by 1 of this number, which is 1 actually. So the result is this number 0 0 0 0 and 0 0 1 0. Okay, so that's it. This is the result here. Okay, what is this actually? I know that this is 2. Okay, here I have it. This is 2. Okay, so now this is 2 in decimal actually, you see. So I think that when I'm going to run this code, okay, I'm going to get 2. Let's try this. I have 2. Okay, so that's it. The last one is going to be bitwise shift right. So that's it. Okay. I have 2 to be shifted to the right by 1. Okay, this number 2 is going to be shifted to the right by only 1. So let's try this. It's pretty like this. Shift right by 1. We have 0 here, and that's it. Okay, it's going to be equal to this. Okay, it's shifted to the right by 1, and that is 1, you see. So let's run this, and I'm getting 1, so I'm right. Okay, so these are the bitwise operators in C or C++ language. Okay, so that's it. If anyone has a question or something, please go on and raise your hand. I'm waiting for you.
Can I speak now?
Yes, go on.
If I want to shift a number by another number, as for example, when I shift left 1 by 3 places, and I want to replace these right zeros with another digits of we can say binary of the two. We can make it all after left shifting, right?
Sorry, I couldn't understand well actually. I think you have said something like you want to shift this number like this, okay, but you want this not is going to be 0. You want this to be 1, something like this.
I mean when I left shift this number by we can say three places, and so we have the we have the zeros at the right side. So I can so I want to replace these zeros by another digits and not just zeros. I can make just making ordering with another number, so these zeros are replaced by the order number, not just zeros.
Okay. I want to say something that the only way the only digits you could use are zeros and ones here at our case here. We are talking in binary right now, so you couldn't put any characters other than ones here. Okay, at this case. Actually, you could achieve this by making something that we are going to talk about right now. That's called bit masking. You are going to explain something called bit masking.
Okay.
Get ready for it. Okay, and also if your question is not answered, go on and ask it again. Okay.
Okay, got it. Thank you.
Welcome. Let's get it back. Actually, I think we are going to have a break after 10 minutes. I mean, something like this. Okay. So when our meeting is going to be restarted, we are going to take a break for 5 minutes or something. Okay. Okay. Let's get it back. Now we are going to talk about something called bit masking and bit manipulation. Okay, bit masking and bit manipulation. Of course, I mean we could consider these topics as the same. Bit masking and the manipulation is the same topic actually. I consider these are the same one, but masking and the manipulation are going to be two names for the same. I think the same behavior actually. So now let's get into this topic. Okay. I want to say that we are going to explain some things like how to set a bit and how to reset a bit, how to read a single bit, we are going to make something called masking using left shift. Okay. I want to say something that you could reverse these two words. You could write right shift here. I could write here bitwise right shift. Okay, and this is could also be written like left shift. So here we are when we are going to program in C++, we could use the both expressions, left shift or shift left. Okay, right shift or shift right. Okay, so they are the same actually. Okay, so that's it for now. Let's get to our example. I have prepared some examples here for you. Okay, I have finished of this. Masking and the manipulation. Okay, that's the first example. Okay. Let's take only this. yes, I have here a variable that has 1 as its value, okay, and now I'm going to print this variable, the value of this variable, okay. Then I'm going to manipulate this variable. I'm going to make some manipulations and some masking on this variable. So let's see what is this about actually. Okay, here I have a requirement that tells me that you need to set a bit. How to set a bit? I want to set the bit number 5. I want to set the 5th bit within this number or this variable, which is a. Okay, so now we are going to talk like this. I have a, which is 1. 1 is going to be equivalent to this 0 0 0 0 0 0 0 and 1. Okay, so that's it. I want to set this bit. Okay, so I have here, like, if these are the orders, so the 7 6 5 4 3 2 1 and 0. Okay, I want to set this bit. I want this bit to be 1. This is the 5th bit. Okay, the bit number 5. I want to set this bit. What shall I do? Okay, actually there is something that I could do here that is based on the OR operation. Okay, I mean that from the truth table of the OR operation, okay, you know that the only case that the output of the OR operation is going to be 0 when all its inputs are 0. But when you have only one bit that has 1 as its value, it's going to be ORed with anything. It's going to be the result of 1. Okay, I mean, let's get back to the truth tables of this OR operation. Okay, I mean like this. I'm going to copy this from here. Yes, this is a truth table for the OR operation. Okay. Okay. I want to set bit number 5. How could I achieve this? I'm going to revise my truth table. Okay, and I'm going to get a result from this. Okay. Okay, we have two results actually you could get from this table, which are something like when you have anything ORed with 1, okay, so you got 1, and when you have anything ORed, or I mean something, okay, it's better here to use this expression. Something ORed with 1 is going to be 1, and something which is ORed with 0, it is going to be the same something. Okay, so now what does this mean actually? When you have here something or anything that's ORed with 1, the result is going to be 1. If you have 0 here, 0 ORed with 1 is going to be 1. Okay, and if you have 1 here, 1 ORed with 1 is going to be also 1. Okay, so that's it. I mean, this is something. Okay, but if you have something ORed with 0, okay, like you have here one OR with 0, you are going to get 1, and 0 ORed with 0, you are going to get 0. So that's it. Okay, so I mean literally something or anything that's going to be ORed with 0 you are going to get the same thing. Okay, okay, so that's it. These two results that comes from or come from this truth table, actually, I mean I'm going to copy this here, so that's it. Okay, you could see these two rules here are going to be present here, actually. 0 ordered with 0, 0 ordered with 1, 0 ordered with 1. These three, okay, represent this rule, and this, okay, or I mean this three rules also are going to represent this rule. Okay, so you got these two rules here. Okay, we are going to use these two rules, okay, to manipulate this number, which is 1 here, okay, to reach our requirement, which is setting this bit number 5. When I'm going to say set bit, I want to say that I need it by 1. Okay, set means 1 here. Okay, so I want this to be 1. How I could achieve this? I'm going to make something called bit masking. I'm going to achieve this bit manipulation by bit masking. Okay, I'm going to have something called mask. So I'm going to copy this here to be manipulated. Okay, then I'm going to use my OR, my bitwise OR, actually. Okay, then I'm going to write here something called mask. That's I'm going to make. So what's this mask about? It is about manipulating a certain bit, okay, that I want to manipulate it without affecting any adjacent bits. Okay, so I want to manipulate the bit number 5 here, actually. So what I'm going to do is to make bitwise ORing of this bit with 1. Okay, so I need to put something like 1 here. Okay, so this is going to be ORed with this one, so the result here is going to be 1 for this bit. So I have manipulated this, but I want to make no change to these adjacent bits. These adjacent bits should be the same. They should be the same. They shouldn't be manipulated at any manner. Okay, so how I could achieve this? I could put all these adjacent bits to zeros. So when I'm making ORing of zeros with any, I'm going to get the same, like this rule says. Okay, so that's it. Here you see that when I'm going to make OR between 1 and 0, I'm going to get this one as the same, so I get this. You see how I made my requirement to be achieved. Okay, I wanted this bit, the 5th bit, to be 1, so I have made a mask here. This is called mask, actually. This is mask or a bit mask. Some people call this a bit mask. Okay, so I have make some masking here. Okay, and make this operation. I made this OR operation, this bitwise OR, so I got this result. What is this result about? It is about making this bit by 1. Okay, so how I could achieve this? By making this mask. What does this mask equal to? I'm going to make an investigation about this. So I'm going to my table here and work on this. I have 0, 0, 1, 0, 0, 0, 0, 0. Of course I'm going to get 32 here. Okay, so this is 32. So this is equal to, okay, I'm not going to write this here, I'm going to write this here. This is 32 actually. Okay, so I'm going to make some o-ring with 32. I have made this in my code here. Actually, I have written a is equal to a ORed with 32. So now I got the result here. You see? So let's run this. Actually, I'm printing a here after I have made this masking. So this is bit masking, which made my needed manipulation, my bit manipulation here. Okay, and this is a mask. 32 is a mask actually. Okay, let's run this. Here I have a is equal to 1 from this statement, and now I have a is equal to 33 from this statement. Actually 33 is going to be, when we are going to our notes here, I need to represent 33, so I could have 0 0 then 1. So now I have 1 lifted. Okay, so I have 1 here, so this is 33. Okay, you see that I have set this bit. Okay, I have set the bit number 5 here. This is number 5 actually. You see this? Okay, very good. Okay, now we are going to the second requirement, which is how to reset a bit. Okay, so it's pretty the same actually. Okay, let's try this. The requirement here says that I need to reset bit number 0. What is this about? Reset means here put it with 0, put it with a new value which is 0 actually. Okay, so now, okay, I need to copy this truth table for the AND operation actually. Yes, that's it. Yes. Okay, it is the same actually here. So that's it. I have the same problem statement, but with some minor changes. Now I'm going to reset bit number 0, which is this bit. I want to change this bit to be 0. How I could achieve this? Okay, now I have the truth table for the AND operation actually, and I'm going to write some rules, some 2 rules like this here. The first one is going to be something, okay, which is ended with I mean here I have written, okay, something which is ended with 1 is going to be the same thing actually, and now I have something which is ended with 0. It is going to be 0. So that's it. Okay, now if you have anything here, you are going to write like 1. So now 1 is ended with 1, you are going to get 1. Okay, and also when you have 0 ended with 1, you are going to get 0. So that's it. Okay, that's what meant by something here. And also here we have another thing that says if you have something which is ended with 0, okay, like we have 1 here which is ended with 0, you are going to get 0. And if you have 0 which is ended with 0, you are going to have 0 also. Okay, so that's it. Of course these two rules are present here within this truth table. I mean that something ended with 1, like here, okay, like these 3 entries in the table, you have 1 ended with something. 1 is ended with 1 here, you have 1, and 1 is ended with 0 here, you have 0, and you have 1 which is ended with 0 here, you have 0. Okay, so these 3 entries represent this rule, and actually these 3 rules here represent this rule. Okay, 1 here is ended with 0, you got 0. 1 here is ended with 0, you got 0, and the 0 here is ended with 0, so you got 0. So that's it. It's very easy. Okay. Okay, Omar, go on.
I was asking about the previous method. It's called masking as it masks all the bits except the bit we want to change, or why it is called this way.
Again, please.
I asked the name of bit masking method. It is named that way because it masks all the bits except the bit we want that change. Is it correct?
Yes, it's correct. You are correct. Your expression is correct. Yes. Okay, I have answered your question.
Oh, okay.
Very good. Now, we need to reset this bit. Okay, so let's make it here, like we have made this here actually. Okay, we are going to use the AND operation for resetting a bit. Okay, how we could use this? Okay, actually we need to change this bit only. So to achieve this, we want this to be 0, so we could AND this bit with 0. Okay, and to make these bits not to change it, we need to have ones for these in our mask. Okay, so you are going to write 1 1 1 1 1 1 and 0. Okay, so that's it. Here we are going to make the same operation. This ANDed with this are going to be zeros here. Then 1 is ANDed with this 0 is going to be 0, so we have resetted our bit. Okay, I want to say something here, that in these bits we have satisfied this rule. Actually, something ANDed with 1, we have ANDed with 1 here, so something is ANDed with 1, you get the same thing here. Okay, but 1 which is ANDed with 0 is going to be 0, so we have satisfied this rule in this place. Actually, you see, I want to say that if we have here something like 1 here or something, so when we are going to making the AND operation here with these ones, we got this as 0 0, and when we came here, 1 ANDed with 1 is going to be 1, and then zeros, then 1. Okay, so that's it. You have made the operation without any change in these bits, so this is called bit masking. Okay, and also I'm going to make it back to its original form. This is called bit mask. Okay, it is 254. This is our mask here. Okay, you see. So now we are going to make this in our code. Okay, how to reset a bit? Reset bit number 0. So I'm going to have my A ended with bitwise ended actually with 254, and I'm going to print the result. I mean the result should be zeros or 0. So yes, I have it here. A equals to 1, then A equals to 0. So that's it. Okay, so this is called bit masking. I think I have one more entry here. Yes, how to read a bit actually. Okay, so let's try this here. Okay, okay, thank you here. Now I'm going to make a new thing actually. Here set bit number 5 and here reset bit number 0. Okay, the new thing I'm going to make here actually is going to be something like read bit number 5 of the variable A. I could achieve this. Okay, I could achieve this using the AND operation also. How I could do this? Actually, I have used this rule. Okay, when I'm going to have something ended with 1, I'm going to get the same thing actually. Okay, so I have used this rule for this purpose actually. When I have something like A, which is this value, okay, I mean this is should be 0 actually. Yes, I want to read bit number 5, which is this bit. I want to read this bit. Okay, I could read this bit. Okay, I'm going to make and with some mask here, which is going to be 0 0 1 0 0 0 and 0 0 0. Okay, so that's it. Means there is one bit. Okay, so when I'm going to make the AND operation between these two, okay, I mean something like this. I'm going to read, I want to read if this fifth bit, okay, is 1 or 0. I want to make sure if this bit is 1 or 0 actually. Okay, how I could achieve this? I could read this bit using this mask. I have made this mask. Okay, actually this mask is equal to 32. Okay, and also this is called a mask or a bit mask. Okay, so
تمام، فاللي هو ايه ممكن ناخد بريك 5 دقايق وبعد كده نرجع تاني. صح
Yes.
كده يا باشمهندس؟
Yes, we are on a break time. Yes.
Sorry for talking in Arabic.
No, 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 no problem. No problem. Okay, back to our session. Okay. Okay. I was saying that we want to read bit number 5 of the variable a. Okay. So I have this variable a, this value. I want to read the bit number 5 of it, which is 0 now. So I'm going to make this mask, okay, and I'm going to make the AND operation here. I'm using this rule actually, where something is ANDed with 1, you are going to get the same thing actually, okay. So here I'm going to get the same value for this bit actually. So that's it. If I'm going to get this as zeros, so now you know that this bit wasn't actually, this bit wasn't 0, sorry, wasn't 1 actually, it was 0. And if I'm going to get this as 1, if this bit has 1, so this is going to be ANDed with this, okay. So you are going to get this value. This value evaluates to logical 1 actually. Could be a logical 1. I have explained what's a logical 1 actually. So this is a logical 1 or logic 1, okay. So I mean this means that this bit has its value as 1, okay, not 0. So back to our old state again. I have here this code. I want to read a bit, okay. Please read bit number 5 to make a decision on its basis. You need to make a decision on the basis of its value, if whether it was 1 or 0, okay. So now I'm going to use this mask actually, which is 32, okay. So here I'm going to use if condition with my variable, which is a, and with the mask here. This is the mask, which is 32, okay. And if I'm going to get the result as logical 0, all zeros, okay. So now I'm going to print not okay. I'm going to execute this else part, and if I got this as logical 1 here because of the existence of 1 within this bit, the 5th bit, okay, so I'm going to print okay on the screen. So let's run this. So I have here a is equal to 1, then not okay. What happens if I change this to 33, okay, and run this again? So now I have okay printed on the screen, so it works. So I think I have finished the first third points actually. So any questions here? I need to, yes, go on.
I have an idea on this topic. One shift left by like
I'm going to explain this. Okay, yes, you are right actually. Your idea is right, okay. That's the next program. Yes, you are true. Okay. Okay. So Muhammad here has mentioned something that we could, and I'm going to explain this here actually. Masking using the left shift. Okay, how we could achieve this. Okay. So now we are going to this topic here. Okay, I don't need this anymore. I'm going back to the same example actually. So let's get it from its beginning actually. Okay, it's 1 now. A is going to be 1. How to set a bit? Okay, I need to set bit number 5. Okay, how I could achieve this? Here I have chosen 32 to be my mask because 32 is equal to this value actually, which has 1 on its 5th bit. Okay, so what happens if I'm going to make something seems a little odd, but it is the same actually. I'm going to not use this, but let me print something like 1 which is shifted by 5 actually. Okay, what is this about? Let's take this here. Okay, I mean that I have 1 shifted left by 5. Okay, actually 1 is going to be this value 0 0 0 0 0 0 0 and 1. I want to shift this left by 1. Okay, so the result is like you have the same value actually. Okay, but you are going to remove all of these. Sorry, you are going to remove all of these actually and add 5 zeros here. 1 2 3 4 5. Okay, so that's it. So this is a new value for it. Okay, and it is the same actually. It is the same as 32, right? Like here actually, and like here also. You see, this is the same actually. You have 1 on the 5th bit of your mask. Okay, or your value actually, your new value. So this is the same as this. Okay, when you are going to use the left shift actually operator on 1, you are going to have 1 and shift this 1 by some value, you are going to get your mask. So I could go here and print this on my screen to make sure. So I have 32. Okay, let's use this for it actually. Instead of writing 32 here, I'm going to write 1 shifted by 5, and that's it. It is the same. Let's run this. Okay, we have the same result as before. A is equal to 33. So now we could achieve our masks using our shift operator actually. Okay, so it is very useful to use the shift operator, and also it is very simple. It's more simpler than using numbers like 32. Okay, so now you are going to say that what I'm going to set, I'm going to set bit number 5. So actually I'm going to write 1 then shifted by the number of the bit I'm going to set it. Okay, what if I'm going to say that I'm going to set bit number 7? Okay, so I'm going to set to write 7 here. Okay, what I'm going to do when I'm going to set bit number 3, so I'm going to set it here. I'm going to write 3 here. Okay, so that's it. That's my mask here I'm going to use. Okay, it's pretty easy actually. The same applies for the rest of our example actually. I want to reset a bit. Please reset bit number 0. I'm going to remove this, okay, and I'm going to use a mask here. What mask could I use here? I'm going to write 1 shifted by 0, but there is a very very important note here. I want to write the bitwise not operator here before these two brackets. Why I have done this? Because I want to make the AND operation with 1 1 1 1 1 1 1 0. Okay, so this is the mask I want to use. Okay, how could I achieve this mask? I could achieve this mask by writing 1 shifted by 0. Okay, and of course this is equal to 0 0 0 0 and 0 0 0 then 1. Okay, what happens when I'm going to get the complement of this value? When I'm going to use the bitwise not, I'm going to get something like 1 1 1 1 then 1 1 1 and 0. Okay, so I have got this as my mask here. Okay, how I could achieve this? By using both the shift left operator here and the not. So when you are going to mask your variable with using the AND operation, and you are going to write your mask here, you are going to write not and use 1 with shift left operator and use your bit number here. Okay, you are going to write your bit number here. So that's it. It's pretty easy actually. So let's try this. We are getting 0 here, like the result we have got before. Okay, so now A is equal to 0 because I have reset bit number 0, and now we have zeros. Okay, the last one is the same actually. How could I read a bit? I could use this mask as 1 shifted by 5 actually. Okay, so I'm going to read bit number 5 to make a decision on its basis. This is equivalent to 32 I have written before, so this is right actually. So let's run this. I think there's a yes, I have removed this bracket. So let's run this. Yes, it's true. I have not okay here, and when I'm going to change this to 33, run this, it's okay now. Okay, so you see I have used these shift operators to generate my masks. Okay, I want also to say something. Okay, in C language, when I'm going to write something like this, A plus equals 1, this is like you are going to say A is equal to A plus 1. Okay, and also it's true when I'm going to write something A or bitwise or something like 1 shifted by 5. Okay, this is equivalent to writing something like A is equal to A or with this mask. You see, these both are equivalent notations or equivalent syntax. Okay, so the operator then equals, okay, means that you have written equal and the same variable with your operator. Okay, so they are the same. Anything you could write minus, you could write multiplication, you could write division, and so on. You could write your remainder if you wish, and so on. Also here you could write anything. You could write something like this. Okay, so this is the same actually. Sorry, I'm sorry. This statement is the same like this statement. Okay, so there is no difference actually. Okay, and also anything. I'm going to repeat this again. The first one only actually. Here I have used 32, which is 1 shifted by 5. Okay, now I could write this as 4 here, so you got the same, you got 33 here. You see, that's it. Okay, so this syntax is allowed on the C or C++ language. Okay, they are the same actually. Okay, so we are going to use this. It's very simple actually. It's more simple than the others. Okay, and your shifting capabilities makes you able to use these to generate whatever masks you want. Okay, so that's it. Now, anyone have a question? Please go and raise your hand. Okay, go on.
Can I use such a mechanism in arrays?
Give me an example.
Searching for a specific element in the array, for example, a string of username, and let's say we want to just replace it with another element, with another value. I mean.
Okay, you want to you are going to declare
But it will be done manually. Okay, or how?
What? Yeah, I don't get it completely, but I have got something like you are going to
I talk about just the idea, not the mechanism itself, not the procedure itself, but I talk about the idea of bit masking, or the way we do it.
Okay, bit masks are going to be used with single variables or single values, but when I'm going to declare an array here like this, okay, and I have some values here, okay, something like 1, 2, 3, 4, 5, and 6. Okay, then when I'm going to write something like array of 1 or array shifted right by something here, this is not what you are going to achieve. I think you need to replace something like this with this. Okay, is that what you mean?
Okay, I just mentioned wanted to say that the idea or the way bit masking is done can be done in analogous to the array, but in manual. That's right. It's just the.
You mean you are going to make something like a for loop and manipulate your array?
Yes.
Yes, it's going to be done like this, but here you're shifting. Shifting operators are not going to help you achieve these tasks. You are not going to manipulate these like you are going to replace an element with another, or you are going to shift all of these elements with, like, you are going to make something like 2, 3, 4, 5, 6 and 0 instead of 1, 2, 3, 4, 5, 6. this shift couldn't help you making this.
Okay, thank you.
Welcome, you are welcome. Now getting back, I want to add some more notes, or 3 notes actually, on using these shifting capabilities, or on binary representations in general actually. When I have something like, let's say that we have unsigned character a, which is equal to something like 5 here, then I'm going to print f something like this. Okay, that's a shifted by 1, you see, and now I'm going to make this as shifting by 1, and I'm going also to print shifting by 2. Okay, what's going to happen, what's going to be happened here? I have a with the value 5, then I'm going to run this. Here you see that I have shifted a by 1, then I got 10. When I have shifted a by 2, I got 20. You see, firstly a was 5, now I shifted by 1, I got 10, which is 5 by 2 actually. So here I'm going to multiply 5 by 2 to get 10, and now when I'm shifting for the second time, I got 20, which is the multiplication of 10 actually, you see. So I want to say that when you are going to shift left, actually you are going to multiply your number by 2. You could use your shift operators to multiply your number by 2 actually, when you are going to use this within your variable limit. Actually, you are not going to overflow your storage or your variable or something, but here it is safe actually. I have multiplied 5 by 2, then I got 10 here, then I have multiplied 5 by 4 actually, then I got 20 here by shifting. Actually it's for a computer machine, it's more simple to shift than to multiply by 2. Okay, it is the same like you are going to write something a multiplied by 2, or something like a multiplied by 4. Okay, the shifting, it's more simpler, and it could be achievable more quick, okay, or quicker than multiplication. So the shifting left makes you able to multiply by 2. Okay, so that's it. And also I'm going to say something. When I have a is equal to 100, then I'm going to shift this right by 1 and shift this right by 2. Okay, very good. Let's run this. You see, you have 50, then you have 25. Okay, so it is something like you divide 100 by 2, so you got 50, then you divide 100 by 4, so you got 25. So shifting right is also making some division here. You are going to get the same result as division by 2, or on 2, actually division on 2. Okay, you see, this is the second root. Okay, the third root is something like we are going to check if a number is odd or even. Okay, all the odd numbers like this is an odd number. It has 1 on its last bit, the bit 0 actually. Okay, so let's take an example here. Actually, you see all of these numbers, okay? One here is an odd number, so it has 1 on its bit 0. 254, it's an even number, so it has 0 on its bit 0 actually. 2 is even, you have 0. 3 is odd, you have 1. 32 is even, you have 0. 33 is odd, so you have 1. So all the odd numbers, okay, have 1s at the last bit, the bit 0 actually, okay? So you could do this trick by making something like this here. If A ended with this mask actually, okay, so print odd, okay, so print this as even. Okay, so let's run this. Yes, I think there is an error here. I don't know what is it. Print F. What is it? Print F is not declared. Yes, I have written print F with this uppercase letter. Okay, let's run this. So we have it as odd. Let's change this to 200 or something. Okay, we have it as even. Okay, you see. So this is another note. Okay, so these are 3 notes. Multiply by 2 using your shift left. Divide on 2 using your shift right, and differentiate between odd and even numbers using this mask actually, this mask and this masking operation here. Okay, you see. So that's it for our bit masking and bit manipulation topic. Okay, I think we have finished today. Okay, we are going to continue our sessions for the last week. Sorry, for the next week actually, and also that's my last. I think that's my last session. The next session is my last session. Then, starting from the next Saturday, you are going to meet with Muhammad, and you are going to talk about some problem-solving topics like prefix sum and frequency array, GCD, LCM, and so on. Okay. So now, if anyone has a question or something, go on and raise your hand. Okay, go on.
Is there a competition in the end of this training or something like that?
Till now, there are no competitions, but if we have planned to make it, we are going to inform you. But for now, there are no competitions.
Okay.
Okay. Any other questions? Okay, guys. Thank you so much, and you are going to meet the next week. Thank you.